So let's take a look at the two kinds of problems that we can see here in Chapter 9. The first one is finding an actual confidence interval. So we've got the situation from the previous pages, same information. The directions: obtain a 95% confidence interval for the proportion of voters who are in favor of the death penalty for a person convicted of murder. So with this question, when you want a confidence interval for proportion, first thing you need to do is you need to figure out what p hat is. And we saw that last time. P hat was the 1123 out of 1783. And let's try to keep this as accurate as possible, because when you're dealing with these decimal points are definitely going to make a difference in calculations, especially when you're in MyStatLab. You need to make sure you're keeping a lot of accuracy there. So we're going to get 0.6298 for our p hat. Now, before we go any further, we need to do our check, our normal check, and make sure p hat times 1 minus p hat usually ends there. We need to figure out what that is. So n is that sample size of 1783, then times the 0.6298, then times the complement of p hat, so 3702. Okay, let's see what that is really quickly here. All right, I'm getting 415 and some change. Doesn't even matter. Way bigger than 10, so we're good. So now that we've got that, now we're going to go ahead and say, let's create that interval. To create the interval, remember, it was, and I'm going to write it in that kind of plus or minus form I mentioned, p hat plus or minus the z alpha over 2, and then that basically standard deviation formula, right? There's our formula for the upper and lower bound working into the plus and minus form. Well, this formula needs a bunch of p hats, which we have, needs an n, which we have. That's all we need to figure out. So let's draw our picture. And keep in mind, again, this is really a low and a high. You could put both of them in there, and I usually like to remind myself that's what I'm doing. But really, we just need to find this one. We need to find the value of z alpha over 2. Now, to do that, let's go back to the confidence level we want. We want a 95% confidence interval. So for a 95% confidence interval, that means alpha is that other 5%. It's 0.05. But that means half of alpha is 0.025. So that is the area that we want to consider in each of those tails. Right? This is supposed to be z alpha over 2. The z-score with alpha over 2 to its right. So this is the value we want. Now, remember, this is from the last chapters. If you've got a normal curve and you know area, we need to know area to its left to use inverse norm. Well, if 0.025 is the area to its right, then 0.975 is the area to its left. So we can do inverse norm of 0.975 and get 1.9. If I go 3 places, it still rounds, so 1.960 as our value of z alpha over 2. And once we have that, we can throw all these numbers into our formula. So our p hat is 0.6298 plus or minus that 1.96 times the square root of 0.6298 times 0.3702 all over 1783. All right, now, whether or not you choose to put this in your calculator all at once or maybe throw this in there, it's up to you. I'm going to go ahead and just do what we call the margin of error. I'm going to do just that plus or minus part, partly because it gives some insight as to whether or not I've got this calculated correctly when you look at it separately. Okay, so I'm going to see 0.6298 plus or minus. And so this whole thing here I'm getting as a 0.0224, just to show you what that looked like on my calculator there. So the 1.96 times the square root of, and in this particular calculation, you don't really need to use overuse parentheses. So just decimal times decimal divided by, and then that closes the whole square root. So that gave me my value there. And now we can do the 0.6298 minus the 0.0224. So that's going to be my lower bound of 0.6074. And I'll just go in and change that to a plus and get 0.6522. And so to interpret those two numbers in a sentence form, we would say we are 95% confident that the population proportion of voters who are in favor of the death penalty for convicted murderers is between 0.6074 and 0.6522. So again, to interpret what we just did, why we did all this work, is because we're saying we got this one number, 0.6298 from our sample. We're 95% confident that the true population proportion is somewhere in this interval, below it to above it, right? Between roughly 61% and 65%. That's the interpretation of all this work that we're doing to find this confidence interval. Now, the other question that we can answer, and in some ways this is almost, I'll say, more applicable to the actual practice of finding a confidence interval. You may want to create an interval for any specific set of data, and you may know how confident you want to be, and you may know what is a reasonable margin of error, what it would make sense to say plus or minus a certain amount. This formula here will actually allow you to use all that information to then determine what your sample size would need to be to accomplish that. So going into a survey, going into a sample, this makes sense. You would know, I think it's going to be appropriate to have a 90% confidence level, and I need a margin of error of whatever, again, makes sense for your results. Now, the one thing this requires is a calculation of p-hat, which if you haven't taken your sample yet, you don't have. So notice this is how this is resolved. Either we use an estimate of p-hat based on a previous study, pilot, survey, something, right? Previous information. But if there's no information on the thing you're trying to study, then you have to go with the default p-hat value of 0.5. This will basically give you your largest necessary possible sample size, right? Any smaller values would end up being smaller, but this is kind of like a maximum possible sample size needed. So with that being said, we're going to look at determining the percentage of Americans that only speak English at home, and we need to know what size sample should be obtained if we wish to estimate within 3 percentage points. So when you see that within, that's generally your margin of error. And here is your 90% confidence, right? And we assume they use the estimate from a 2000 census of 82.4%. So with that information, what we've got, and notice there's no checks here because we're just jumping right in. We're determining the sample size we need. P-hat is the previously known 0.824. The within 3 percentage points, that's our margin of error. Now, being percent, make sure that we represent that as a percentage, 0.03. If the proportion is represented as a decimal, represent the percentage as a decimal. Definitely needs to be consistent there. And then, if we want a confidence interval of 90%, we got to do the work there because we do need this z alpha over 2. So that will come from, if it's 90%, alpha should be 0.1 for 10%, and half of that will be 0.05. And so for our normal curve, if we're talking about these tails, each of which has 0.05 in it, if I want to find that number, we use inverse norm, and if 0.05 is to its right, then 0.95 is to its left. So 0.95. And the inverse norm of 0.95 is 1.645. So that will be our z alpha over 2. And then we can just plug them all into our formula. 0.824 for my p hat. I need 1 minus that. I need its complement, so 0.176. And then the z alpha over 2, 1.645 divided by the margin of error. That was where we determined that to be the 0.03. And that needs to be squared. So throwing all that into a calculator. I'll show you what that looks like here in 1 second. So it's 436.04. I can go further, but first of all, let me make sure we see what that looked like. So you've got just the decimals multiplied. Now you do need parentheses here because you need to multiply those two numbers and square them, right? So you need to tell your calculator how to do that appropriately. Now, this gives us a number that's supposed to represent n, and n is supposed to be a sample size. This is saying to obtain this information the way we want with the accuracy and the margin of error, we would need to sample 436.04 people. So you can't sample 0.04 per person, but if we don't sample that extra beyond 436, we're not going to have at least our required results. So always, for this problem, always round up. And so we'll say we should sample 437 individuals.